Hello, good morning, dear students. Welcome to interactive virtual class Nalan once again. I hope all of you are doing well. Students, so in our previous classes, we have been discussing about mixtures. Yes, so let us see. Okay, in today's class, here we see a father coming back from market. Okay, with a bag of vegetables. Okay, so the boy opened the bag, put it on the table. So here we have different varieties of vegetables that we can see. Yes, other example is the cream, milk, yogurt, cheese. So we have discussed about two types of mixtures. Yes, the first type is the heterogeneous mixture and the second given here is the homogeneous mixture. Yes, students, do you recall what is heterogeneous mixture and what is homogeneous mixture? Yes, students, very good. Heterogeneous mixture are those mixture which do not have same composition throughout, whereas homogeneous mixture are those mixtures which have same composition throughout. Okay, so how do we separate this? Okay, in heterogeneous mixtures we have different substance, and in homogeneous mixture also there are different substance. So how do we separate the different components of mixture? Okay, that we will learn in today's class. Okay, but before we proceed further, let us answer the first question for today. Please get your rough devices ready, students, and respond to this question. The question is, solution which has uniform composition throughout is called. Okay, I'm giving you 15 seconds for this question. Your time starts now. Solution which has uniform composition throughout is called. Option A is homogeneous solution. Option B is heterogeneous solution. Option C is colloidal solution. And option D is none of this. Yes, students? Okay, so this is a quick recalled questions. Very good, students. The correct answer is option A, that is homogeneous solution. Solution which has uniform composition throughout is called homogeneous solution. Very good, students. So now let us see separating the components of a mixture. Okay, how do we separate the components of a mixture? So different methods of separation are used to get the individual components from a mixture. Okay, different methods are used. Okay, so let us see. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods. Okay, so what are these simple physical methods? We will look into it one by one. Okay, simple physical methods. So here we see, okay, a woman separating rice from the husk. Yes, so when we are cleaning our rice, we also hand pick, right? We also separate the components, the unwanted components, we pick it and keep it aside. Yes, so the first method, simple physical method, is hand picking. So we can separate the mixture of a component of the heterogeneous mixture by hand picking. But this hand picking method cannot be used for all types of mixture. Okay, taking the examples of different vegetables that the father brought from the market, we can separate different vegetables like potato, tomato, carrots, beans, etc. by hand picking. Yes, so hand picking is one simple physical method to separate components of a mixture. The next we have is, okay, here we see a woman again. Yes, we see that she is cleaning, or she is separating the components of a mixture of a flour. Okay, so this method is known as sieving. She is using a sieve to separate, okay, the larger particles, the smaller particles. So when we are, okay, when we want small fine particles of flour, or we say atta, we sieve it. Yes, so this is sieving method. So another simple physical method to separate components of mixture is sieving. Okay, then next we have is, here we see a woman making tea, preparing tea. Okay, now when we boil the tea, when we want to separate the tea leaf, okay, from the tea that we have prepared, we use this to filter it. Yes, so this is another method. Filtration is another simple method, okay, to separate the components of mixture. So we have discussed about hand picking, sieving and filtration. These three are the simple physical methods which can be used to separate the components of heterogeneous mixture. Okay. Now the next example we have here is milk, petroleum, ink and oil in water. Okay, oil and water. So can we separate this mixture by hand picking? No, right? By sieving? No, right? By filtration? No, right? We cannot filter them, or we cannot hand pick them, or we cannot sieve them to separate their components. So what methods do we use for these mixtures? Let us see. Okay, so sometimes, okay, special techniques have to be used for the separation of the components of mixture. Okay, so what are these special techniques? We will discuss one by one in today's class. Okay, so here we have ink. Yes, method to obtain colored component. We have the ink solution. So how do we separate the component, okay, from this ink, blue or black ink? So this is the setup. Take a beaker, okay, fill it up with water. Take a watch glass and fill it up with the blue ink that you want to separate. Okay, so we have the watch glass, we have water, we have ink in the watch glass, okay, then water in beaker, then we have the burner. So arrange in such a way and turn on the burner, heat the water. We will see that vapors are formed. Yes, so here water has evaporated from the ink and the solid dye is left behind in the watch glass. So in this method, the water present in the ink evaporated, okay, and the solid dye is left on the watch glass. So here we see that the components, that is water and the solid dye, are separated from one another. Yes, so we can separate the volatile component, that is solvent, from its non-volatile solute by this method, and this method is known as evaporation. So evaporation is another method which we can use to separate the components of a mixture, and this evaporation method is used to separate the volatile component from the non-volatile component of the mixture. Okay, all right students, we have another question. Please get your rough devices ready. The question is, a mixture of water and silver chloride can be separated by which of the following? Okay, so I'm giving you 15 seconds to respond to this question. Your time starts now. So we have a mixture of water and silver chloride. How can we separate them? By using which method? Centrifugation, sedimentation, sublimation, filtration. All right students, yes, very good. The correct answer is option C, that is filtration. So a mixture of water and silver chloride can be separated by filtration. Very good students, let us proceed. Here we have milk, cream, yogurt and cheese again. Okay, so method to separate cream from milk. How do we separate cream from milk? Okay, let us see. This could be done using a milk churner which is used in the kitchen of our home. So this is the milk, okay, churner. Using this we can separate the cream from milk at home. Okay, but in the laboratories, centrifuging machine is used to separate cream from milk. Okay, so this is the centrifuge machine. So this machine is used to separate cream from milk. Let us see how. Okay, so take some amount of milk, fill it up, okay, in a test tube or centrifuge or centrifugal tube. Okay, then arrange, put it in the centrifuge machine, then you spin it. So centrifuge it for 2 minutes. Now you will see that there are 2 layers formed in each centrifuge. The lower portion, the upper portion. There are 2 layers now. So here the cream is in the upper layer and the skimmed milk is in the lower layer. So this method is known as centrifugation. So to separate cream from milk, centrifugation method is used. In centrifugation method, the denser particles are forced to the bottom and the lighter particles stay at the bottom when spun rapidly. Okay, so cream is lighter than milk, hence it floats on top of milk. Okay, and that is how we can separate milk, cream from the milk. Applications of centrifugation method. Okay, so where do we use this centrifugation? It is used in diagnostic laboratories for blood and urine test. Okay, so during blood and urine test, this centrifugation method is used. It is used in dairies and home to separate butter from cream. Okay, so using this machine, by using this centrifugation method, okay, we can separate butter from cream. And it is also used, this centrifugation method is also used in washing machines to squeeze out water from wet cloths. Okay, so these are some of the applications or uses of centrifugation method. Alright students, we have another question. Please get your rough devices ready. The question is, how can we separate cream from milk? Okay, I'm giving you 30 seconds for this question. Your time starts now. Yes students, how can we separate milk, cream from milk? Option A is centrifugation. Option B is chromatography. Option C is sublimation. Option D is distillation. So which of the following method will we use to separate cream from milk? Alright students, your time is up, and yes, very good. The correct answer is option A, that is centrifugation. We separate cream from milk, okay, by using centrifugation method. Alright students, again come back here. We see here a woman, okay, putting a packet of oil into a container. Then she realized that there are some amount of water at the bottom of the container. Then she expressed saying, "Oh, what did I do? A packet full of oil is wasted." Okay, so she mixed the oil with water by mistake. Okay, so she was regretting, saying that she has wasted a full packet of oil. Okay, a packet full of oil. So here, liquid which do not mix with each other are called immiscible liquids. Remember this term, okay students? When we mix water with oil, we see that they do not mix with one another, but two layers will be formed. Yes, so these liquids which do not mix with each other are called immiscible liquids. Okay, so method to separate a mixture of two immiscible liquids. How do we separate two liquids which does not mix with each other, or known as the immiscible liquids? So taking the example of this water and oil, add some amount of water into the beaker and add some amount of oil into the beaker, okay, into the same beaker. Now we see two layers. Yes, the first layer of water and the second layer of oil. So we have these two are immiscible liquids. So how do we separate them now? So here, before looking into the method, let us answer this question. Oil floats on top of water. Okay, you can try this at home. When you mix water with oil, you will see that the layer of oil is at the top of the water. Why is this so? Okay, let us find out. It is because the density of water is greater than the density of oil. Hence, the layer of water will fall below, will be at the bottom, and the layer of oil will be at the top. It is because the density of water is greater than the density of oil. Okay. Now let us see. The instrument used to separate two immiscible liquid is known as separating funnel. Okay, so this is the instrument used to separate immiscible liquid, and this instrument is known as separating funnel. Okay, so let us see how do we use this separating funnel. So first, pour the immiscible liquid, that is the oil and water, into the separating funnel. Okay, then shake it. Okay, then we have two layers. Now the first layer at the bottom, the water layer, is removed from the bottom like this. Okay, Now if the layer of water is removed, then you stop the flow of this liquid, then we have separated the water and oil into two components. Okay, so this is how we separate two immiscible liquids by using separating funnel, and this method is known as separating funnel method. Okay, separating funnel method. So immiscible liquids can be separated by using separating funnel. Okay, so this is another method to separate components of mixture. Now let us see some applications of separating funnel method. What are some of the applications of separating funnel method? The first is separating funnel method is used during the extraction of iron from its ore. Okay, so here this is the blast furnace. Let us see here. Here we see that the slag are removed from this layer and we have the molten iron here. So the lighter slag is removed from the top, leaving the molten iron at the bottom in the furnace. By using this separating funnel method, we can separate the iron from its ore. Okay. Alright students, let us see here another mixture. Let us mix salt and iodine. Okay, let us mix salt and iodine and see. So take some amount of iodine, take some amount of salt and mix them. Okay. So we have mixture of salt and iodine. So how do we separate them? Okay. Before we look into that, let us answer one more question. Please get your rough devices ready. The question is, when two liquids do not mix, they form two separate layers and are known as dash. Okay, so which of the following option is the correct answer? I'm giving you 15 seconds for this question. Your time starts now. When two liquids do not mix, they form two separate layers and are known as option A miscible liquids, option B immiscible liquids, option C saturated liquids, and option D is supersaturated liquids. Alright students, your time is up, and yes, very good. The correct answer is option B, that is immiscible liquids. When two liquids do not mix, they form two separate layers. They are known as immiscible liquids. So yes, very good. The correct answer is option B. Alright students, method of separation of salt and iodine. So here, some substance when heated change directly from solid to gas without changing to liquid state. Okay, some gases when cooled down gets converted to solid directly without changing to liquid state. Okay, so solid when it's heated, it changes directly to gas, and when gas is cooled, it changes directly to solid. So these substances, this type of substances are called sublimable substances. Remember these terms, okay? Sublimable substances are those substances when heated change directly from solid to gaseous without changing to liquid state, or when cooled it change from gas to solid directly without passing through the liquid state. Okay, so those substances are called sublimable substances. Some of the examples of sublimable substances include iodine, naphthalene, camphor, ammonium chloride, and anthracene. These are some of the examples of sublimable substances. Okay, so here sublimation, okay, this method to separate the components, okay, that is salt and iodine from the mixture, we use sublimation method. Okay, so what is sublimation? Some substances when heated change directly from solid to gas without changing into liquid state or vice versa. This process is called sublimation. Okay, so experiment for sublimation. Let us see. Materials required are iodine granules, salt, Bunsen burner, test tube, funnel, and china dish. So let us see. We have the burner, we have the stand, we have petri dish, okay, or china dish. Now add some amount of iodine granules into the china dish. Okay, then add some amount of salt into the china dish and mix it. So we have the mixture of salt and iodine here. Yes, we have the mixture of salt and iodine in this china dish. So let us turn on the, okay, before turning on the burner, take a funnel, cover it, and on top of the funnel put another test tube. Okay, so we have inverted test tube, we have the funnel, we have the china dish, and we have burner. Now turn on the burner and see what happens. Now when you turn on the burner, you will see that some substance begins to evaporate. Yes, we see that it's changing the state. So here the vapors are collected in the inverted test tube. Okay, then we see that the vapors are getting collected in the test tube. So let us see after some time what happens. Remove the test tube. Okay, the iodine are separated. The iodine are formed in this test tube. The iodine are formed in this test tube, and the salt are left behind in the china dish. Okay, so this is how we separate the mixture of salt and iodine by using sublimation method. Okay, so condition for sublimation process. Okay, to carry out this sublimation process, there are certain conditions that needs to be followed. The first is that it should be a solid mixture. Okay, both the mixture should be solid, and one of the component in the mixture should be sublimable substance. Okay, one of the components in the mixture should be sublimable substance. So in our example, we have salt and iodine, both are solid. Then we have iodine as a sublimable substance. Yeah, so this mixture satisfied this condition, and that is why we were able to separate the components of salt and iodine mixture by using sublimation process. Alright students, we have another question. Please get your rough devices ready. The question is, how one can separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride. Okay, I'm giving you 30 seconds for this question. Your time starts now. How can one separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride? Option A is precipitation, option B is sublimation, option C is chromatography, option D is centrifugation. Yes students, which of the following option is the correct answer? Alright students, your time is up. Let us see. Okay, ammonium chloride is an example of sublimable substance. Sodium chloride is not sublimable, but both are solid. So here it satisfies the condition of sublimation process, right? So the components of ammonium chloride and sodium chloride, the mixture, okay, containing ammonium chloride and sodium chloride can be separated by using sublimation method. Yes, so the correct answer here is option B, that is sublimation. Alright students, let us see. Is the dye in black ink a single color? Okay, so this is the black dye. So is this a single color, or does it contain other colors as well? Let us find out. Okay, so this is the black dye. So to find out, let us see. Okay, let us perform an experiment. So first take a strip of filter paper, okay, a long one. Then take a beaker, fill it with water to some level, not too much, okay. Then make a line, straight line, okay, 3 centimeter from the bottom. Then draw a line on it using a pencil. This is the line. Draw a line on it using a pencil. Then put a drop, okay, put a drop of the black ink at this point, okay, at this point. Put a drop, a small drop of ink at this point. Now let us put this filter paper into the water and let us see. Remember students, the water level should not reach this line, okay. The water level should not reach this line. So put the filter paper into the beaker and let us observe what happens. Now we see that the water is rising up through the filter paper. We see that the different colors components are also visible now. So why is this so? How is this happening, or how is this possible? Okay, the ink that we use has water as the solvent, okay, and the dye is soluble in it. as the water rises on the filter, okay, as the water rises on the filter paper, it takes along with it the dye particles. Okay, so the water is moving up this filter paper, the dye particles are also moving up along with the water particles. Okay, so generally dye is a mixture of one or more color. Okay, generally it is a mixture of one or more color. So here the dye which is more soluble in water dissolves first, rises faster and separates to different colors. Okay, so the solubility of different color components is different. Okay, so the color which dissolve first will rise first. So here we see different colors, right? We see yellow, pink, blue, orange. Yes, so the color which dissolves in water first will move faster. Okay, and the color which dissolves slowly or slower will rise slower. So we have different components of the black ink in this filter paper. So using this method we see that we can separate the different components of mixture from a black ink. Okay, so this method, okay, this method is known as chromatography method. Okay, and chromatography, what is chromatography? The process of separation of components of mixture is known as chromatography. Okay, chromatography is the technique used for separation of those solutes that dissolve in the same solvent. Okay, in the same solvent, all the color components dissolve in water. Okay, so they dissolve in the same solvent, and this chromatography technique is used for separation of those solutes which are soluble in the same solvent. Chroma in Greek word means color. Okay, and this technique, chromatography technique, was first used for separation of colors. Alright students, applications of chromatography. What are some uses or applications of chromatography? Let us see. The first point is to separate colors in a dye. The second is to separate pigments from natural colors. And the third is to separate drugs from blood. Okay, so these are some of the applications of chromatography. Method to separate a mixture of two miscible liquids. Okay, so we have water and ethanol. We know that water and ethanol, they mix with each other. Yes, so we have water ethanol solution now. So how do we separate them? In case of water and oil, we have two separate layers. Those are known as immiscible liquids. But here, water and ethanol, they mix with each other. So these mixture are known as miscible liquids. Okay, so how do we separate them? Liquids that mix well with each other are called miscible liquids. Method to separate a mixture of two miscible liquids. So this is the apparatus that we will use, okay, to separate a mixture of two miscible liquids. So we have the distillation flask. We have the mixture of acetone and water in this flask. We have Bunsen burner. We have acetone pipe. Okay, we have water condenser. We have cold water, and we have the thermometer. So we will use this apparatus to separate the miscible liquids. This is a mixture of acetone and water. Okay, so the boiling point of acetone and water is different. So when we heat it, one of this acetone or water will evaporate first, then it will condense. Then here in this case, acetone will evaporate first. Okay, so when we heat it, the water will be left behind. The acetone will evaporate, then it will come through this condenser, and from this condenser it will be again converted to acetone, which is collected through this pipe. Since the boiling point of water is more, they will need more temperature. Yes, so before the water starts to evaporate, acetone will evaporate first, and that is how we can separate the mixture of two miscible liquids. Okay, so here we see that the volume will decrease once the acetone evaporate from the flask. Okay, so distillation, this method to separate the mixture of two miscible liquid is known as distillation. Okay, so the method used for separation of components of containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling point is called as distillation. Okay, to separate, okay, or to use distillation method to separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 K, fractional distillation process is used. Okay, the difference, the boiling point temperature difference, okay, if it is less than 25 K, then we cannot use distillation method. Okay, so we have to use fractional distillation process. Okay, so let us see. Before we proceed further, let us answer one more question. The question is, common method used to separate dyes is, okay, I'm giving you 15 seconds for this question. Students, your time starts now. Common method used to separate dyes is option A, distillation, option B, chromatography, option C, filtration, option D, sublimation. Alright students, your time is up, and yes, very good. The correct answer is option B, that is chromatography. Okay. Alright students, so fractional distillation. What is fractional distillation? In fractional distillation, we have different apparatus, and apparatus a little different from the apparatus which is used in distillation. So this is the apparatus. Okay, we will learn in detail for fractional distillation in our next class. Okay, so a simple fractionating column is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly as shown in the picture. Okay, so distillation application. What are some of the uses or applications of distillation? Let us see. Distillation process is used to separate different gases from air. Okay, distillation process or distillation method is used to separate different gases from air. Distillation method is also used for separation of different fractions from petroleum products. So these are some of the applications of distillation method. Okay, all right students, so in today's class we have discussed about the how to separate the different components of a mixture. We have seen that for heterogeneous mixture we can use some simple physical methods such as hand picking, sieving and filtration. Yes, but for some mixture we cannot use the simple physical method, and there are some special techniques which we need to separate the components of mixture. Yes, we have discussed evaporation. Yes, evaporation is one of the method which we can use to separate the different components of mixture. Yes, in evaporation we can separate the volatile components from the non-volatile components. Then the other method that we discuss is the centrifugation. In centrifugation, the examples that we discuss is to separate cream from the milk. Yes, so in centrifugation the denser particles, okay, it will be forced to settle at the bottom, okay, and the light particles will be at the top, and that is how we separated the skim milk and the cream by this method, that is the centrifugation method. We have discussed the applications of centrifugation method, which includes use in diagnostic laboratories for blood and urine tests. Then centrifugation method is also used in dairies and home to separate butter from cream. Yes, and centrifugation method is also used in washing machine to squeeze out the water from wet clothes. Okay, now the next method that we discuss is the separating funnel method. Yes, in this method, separating funnel method is a method which is used to separate components of immiscible liquids, liquids which do not mix well with each other. The example we took was water and oil. So by using this separating funnel method, we can separate the immiscible liquids. Okay, some of the applications of separating funnel method includes it is used during the extraction of iron from its ore. Yes, the lighter slag are removed from the top and the denser iron ore or the metal ore is collected at the bottom. Okay. Now we have also discussed about the method of sublimation. Yes, what is sublimation? Sublimation is the process where the substance, when heated, directly convert from solid to gas, or when cooled, directly convert from gas to solid without passing through the liquid phase. This process is known as sublimation, and this sublimation method can also be used to separate different components of a mixture. Okay. Now for sublimation process, okay, to use sublimation process, we there are two conditions that need to be satisfied. The first is that the mixture should be solid mixture, and the one of the components should be a sublimable substance. Okay, those substance which directly change from gas to solid, or from gas to solid, or solid to gas directly without passing through the liquid phase are called sublimable substance. For to use sublimation method, one of the substance should be sublimable substance. Okay. Alright, so then the next we discuss is chromatography. Chromatography is a technique used for separation of different components of dyes. Yes, we have seen that it is used to separate the components, or it is used to separate those solutes, those components which dissolve in the same solvent. We have seen the examples of separating of different colors from the black ink. Yes, and this chromatography has many other uses, such as it is used to separate colors in dye, it is used to separate pigment from natural color, and it is used to separate drugs from blood. Okay. Then we have also discussed about distillation. Yes, distillation is another method which we discussed today, and for this distillation method, okay, it is used for separation of components of mixture containing two miscible liquids. Miscible liquids are those liquids which mix well with each other. Okay, but again, to use distillation method, there must be a difference, a sufficient difference in the boiling point of the liquids, of the two liquids. Okay, we have seen the example of acetone and water. The boiling point of water is much higher than the boiling point of acetone, and that is why we are able to separate them by using distillation method. When we heat the mixture of water and acetone, acetone will evaporate first, and then in condenser it will condense to acetone, which is collected. The water remain in the flask. Yes, so this is how we separate the miscible liquids by using distillation method. Some of the applications of distillation method includes to separate different gases from air, and in separation of different fractions from petroleum products. Okay, we have discussed one more point, that is the fractional distillation. If the boiling point difference between the two miscible liquid is less than 25 K, okay, less than 25 Kelvin, then we cannot use distillation method, but we will use fractional distillation. Fractional distillation is a little different from distillation, which we will discuss more in details in our next class. Okay, so this leads us to the last question for today. Students, please get your rough devices ready and respond to this question. Okay. The question is, how do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. I'm giving you 25 seconds to respond to this question. Your time starts now. Yes, students, how do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. Kindly give your feedback about today's class. Alright students, your time is up. Thank you so much for your response, and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.